Hello everyone and welcome to this video on Autodesk Fusion 360. In this video we are going to be looking at how to apply assembly joints in order to create the tripod component or the tripod assembly that you can see on screen now. So hopefully you can see that this tripod has been constrained so that we can move the legs of the tripod, we can slide the legs in and out in order to increase the height, we can move the ball joint at the top, and we can move the thumb screw on the side. So I'm going to go cover how we create each of these joints in turn within the Fusion 360 environment. In order to do that, I've started a new assembly. So here I've simply created a new design, and then I've dragged and dropped each of my individual components into that design. So just drag them from the data panel, drop them in there, and that gives me this situation that we're in now with all of our components listed in the browser on the left hand side. At present, all of these components are completely free to move in space. They're also completely free to move through one another. There's no collision detection or anything like that on. They're all just in their own spatial position. So the first job with any assembly when we're using sort of a drag and drop approach in this way is to ground a component, an important component which we can then assemble the rest of the components to. So in this particular example, I'm going to ground the head of the tripod, and then I'm going to assemble everything else relative to that. So the tripod head is the first component that I've dragged in, so I can right click on that and press ground, and I can now see that I can't move the head component around. I can still move all of these other components, but I can't move the head component. So I will start with the camera attachment component and the thumb screw first of all. First thing I need to do is create a joint. So if I go to assemble and joint, again you're going to see this dialog box relatively often. If you move or grab and manually move any of the components in the modeling environment, Fusion wants to know whether you want to keep them in their current position or whether you want to snap them back to their original position before you create the joint. I'm just going to capture position and carry on. So for this component on the top, I want to snap the center of this sphere to the center of the sphere on the head component. And by default, Fusion has assumed that I'm creating a rigid joint, and actually I'm not. Here I would like to create a ball joint. So if I go to motion, I can select ball, and Fusion will animate how that component is going to move relative to the tripod head. This looks correct, so I can press, just check it again with the play or the animate play. So I'm going to press OK. Now, if I grab the camera attachment, I can see how I can spin that around freely. One thing I don't have as of yet is any collision detection between the head of the camera attachment and the tripod head. They can just move through each other. If you want to rectify this, you can use what's called contact sets. I'll show you how to apply one here. These should be used sparingly because they require a reasonable amount of computational power, especially when we're not just assembly modeling, but if we're using something like finite element analysis or stress simulation. We should try and avoid these where possible. So if I go to assemble and I go to enable contact sets, I'll now see a new group of contact sets, and then if I go to assemble again and new contact set, I can enable a contact set between this component and this component, and I can press OK. Now at that point I should be able to see that I can move, I can still move the camera attachment, but I can only move it in a position where it doesn't interfere or collide with the head of the tripod. That all looks good, so I'm going to leave that in position, and I'm going to focus on the thumb screw. So again, I'm going to create a joint, so I'm going to go to assemble and joint. Again, I want to capture the position, and this time I'm going to create a joint between the center of this face and the center of this hole. So I'm going to hover over this edge, so I've got the center of that circle selected. I'm going to hover over this edge, so I've got the center of that, hover over this cylindrical face, so I've got the center of that selected. Now Fusion will default to selecting the last joint type that you picked. So if I go to motion, this has got ball type by default. Actually, I want this as revolute, so I want the thumb screw to spin in this manner. That all looks okay, but I can see I've got a little bit of interference here. So if I go back to my position dialog, I can just get this arrow, or click this arrow and drag that out slightly. That all looks good, so I'm going to press OK. Now, at the minute, I might be a bit concerned that my thumb screw is interfering with the camera attachment component. We can probably see that that's the case by sort of hovering over this, and we can see that yeah, there is an interference there. One really useful feature that we can use when assembling components in this way to check where their position is relative to one another is we can use an inspect and section analysis feature. So if I go to inspect and section analysis, it will ask for on what face I want to create a section. So in this case, I want to pick the XZ plane of the assembly, and that will immediately cut the entire assembly along that plane, and it will show me a cross-sectional view. So if I press OK, that will remain in place. Now, the important point to note is that this is just an analysis. This does not actually cut our assembly. This is just a view to help us with assembling components. If I go up to the analysis folder here, I can see I've created this section analysis, and I can turn this on or off at any time in order to get that view back or go back to a normal view. So I'm just going to leave it on for now, and what I'm going to do is I'm going to change this joint that I created here, and I'm just going to move that out until it looks about right in terms of its clamping position on the ball, and that looks about okay. So I'm going to press OK. That's done with, so I can disable that section analysis. So that's the head of the tripod assembled correctly. So now I want to look at the components underneath. So the first thing I need is the bracket component. So if I look at my completed assembly, we'll just look at how this is assembled. So I have a bracket, I have 3 hinges on it, and then I have the legs which connect to that particular bracket. So I need this component here, and I want to attach this rigidly to the underside of my tripod head. So again, I go to Assemble and Joint, and this time I want the center of this circle, and I want the center of this circle as well. We can see how this is defaulted to the last selected motion type, which is revolute. We don't want this time we want rigid, so I'm going to change that to rigid. That looks good, so I can press OK. Now for the sake of time saving here, I'm just going to build up one leg, but hopefully you can see these joints would be identical for all 3 legs of the tripod. So the first part of this joint is the hinge pin. So again, I go to Assemble and Joint, and I'm going to fix the center of this face to the center of this face, and we can see how that's been brought in incorrectly. It's the wrong way around, so we can just use this flip button here, and that will put that pin in the right position for us. I do want this rigid this time, so I'm going to press OK. And then the next component that I need is the top, or the leg portion of this hinge, which is this piece here. So again, I go to Assemble and I go to Joint, and I'm going to fix the center of this face to the center of this face here. That looks like it's in the right position, but this time I don't want it to be rigid. I want the revolute joint type. I want this to be able to move, and we can see that animating there. I'm happy with that, so I can press OK. And just to double check, I can grab this component, and I can move it backwards and forwards. Next component that we have is the top of the tripod leg, which is this component here. So again, I go to Assemble and Joint. I want to capture my position, and what I want to do this time is I want to fix the center of this rectangular face to the center of this component here. So I'm going to pick that center position there, and I'm going to pick that center position there. Now, what you'll see is that Fusion 360 has brought the hinge component over to where this this top component, or top of the leg component, was located. It's done this because of the order in which I've picked it. So whichever component you pick first, that is the component which is moved to be closer to the other component. It doesn't actually matter in this particular case, because as soon as I press OK on the joint, the only way that Fusion will be able to resolve that joint is by moving this component over to the hinge. So if I go to motion here, this time I want a rigid joint, and we can see that this is exactly 90 degrees or incorrect by 90 degrees. So I can go back to my position tab and I can rotate this by 90 degrees. I'm happy with that, so I can press OK, and as soon as I press OK, we'll see it snap over to where the hinge component is, and hopefully there we'll see that move backwards and forwards like this. Okay, the next component that I need is the top of the tripod leg, which is this component. So again, I'm going to go to Assemble and Joint. Again, I'm going to capture my position, and I want the center of this cylinder, and I want to snap that to the center of this top component here. I do want that to be rigid this time, so that's okay, and I can press OK. The next component is the lower part of the tripod leg. So if I go to Assemble and Joint, and this time I want to assemble the center of this component, or the center of that cylindrical face, to the center here. This time I don't want a rigid joint. I want a joint which allows this component to slide inside inside the tube. So I'm just going to go through my my joint types. Revolut's not doing it. If I try slider, yes, that's exactly the joint I want. So I want the sliding type. I'll just stop the animation there, and then I'll look at the position, and I just want to move this so that there's some overlap of the two tubes. I'm happy with that, so I can press OK. And then the final thing I need on this particular leg is I need the rubber foot. So again, I go to Assemble, and again I go to Joint, and this time I want to fix the center of this face, so this position here, to the center of this face on the edge. So we can see that that's defaulted to a slider joint. So if I go to the motion tab, I want this to be rigid, and if I go back to the position tab, I can see this is upside down. So I just need to press the flip button in order to fix that. That all looks good, so I can press OK, and hopefully then if I just drag some of these other components out of the way, I can see that I've got the head of the tripod assembled, that I've got the ball can move in the head of the tripod, I've got a thumb screw that can move on the side, and I've got a leg that can move here, and they can slide inside the upper tube as well. So that all looks good. Potentially I could expand upon this by adding more contact sets, because I believe at the minute we can move this component until it interferes with the tripod head, but that's just simply a case of going to Assemble, New Contact Set, and then let's do a contact set between this component and this rubber stop component here, and then hopefully we can see then that when we get close to the edge of the component, this just stops and is not allowed to move. The final thing that I'd like to look at is how we can insert standard components into assemblies such as this. So we can see at the minute that this this bracket is nothing's really holding it in. We've got a hole underneath, but there's no bolt or anything holding it in there. So in order to apply a bolt or insert a bolt, I'm going to go to the Insert menu, and then I'm going to go to Insert McMaster Car Component, and this is the online library of components which we can insert into any of our Fusion 360 designs quite easily. So I want to go to Screws and Bolts. As soon as I'm in here, I want to enable the filter for metric, and for this particular application I want a round head screw, with a Phillips style head, and we'll just pick a stainless steel pan head, and from memory this is a M3 bolt, which is about 8mm long. So as soon as I've found the correct bolt, if I just click on it, I'll get a little drop down here and I can go to product detail. And if I scroll to the bottom of this, I can download this model in sort of whatever format I choose. If we want the 3D models to be inserted directly into Fusion, then we need to make sure we have 3D step enabled. And as soon as I pick 3D step, I can press save. What this will do is it will download the model for the bolt, and then it will insert it into our assembly. So we can see that's the bolt there. So if I move this outside of the component or outside of the rest of the assembly components, and press OK, I can then put a joint in to position that bolt correctly. So if I go to assemble and joint, capture position, and I want the center of this face here, so I'm going to pick this edge, and I want the center of this face here. I do want that to be a rigid joint, but this is inverted, so I just need to use the flip command there, and then I can press OK. And now I've got the bolt exactly in the right position, and I've not needed to model any of the geometry around that bolt. I've just used a standard component. Okay, this concludes the example for the assembling a tripod within Fusion 360. Obviously, to finish this off, you just need to repeat the steps for that one leg for the other two legs. Hopefully this has been of use to you. Thank you very much for your attention, and I will see you in the next video.